Now we are going to take function values of variables. If you look at this example, find b 2x minus 1 negative 3bx if bm equal to m squared plus m minus 1. Of course, bm means function of m. This is the rule that we are going to follow to find b between brackets 2x minus 1 negative 3b for x. All what I am going to do is to replace 2x minus 1, here look, 2x minus 1, I replace it by m. b2x minus 1 will become 2 times, again instead of m, I put 2x minus 1 power 2 plus, again instead of m, I put 2x minus 1 minus 1. Now I solve this. Of course, this special product 2x minus 1 power 2, it's square of difference. How we solve it? We can write 2x minus 1 multiply 2x minus 1, or we can make first one power 2 minus 2 times the first times the second plus second one power 2. This will be 4x squared minus 4x plus 1. But because it is multiplied by 2, it will be 8x squared minus 8x plus 2 plus 2x minus 1 minus 1. After I simplify it, I will get 8x squared minus 6. Here also the same, only this very simple. Instead of m, we put x. It will become 2x squared plus x minus 1. Here we get the answer. We put 6x squared plus 3x minus 3. Of course, because I replace here m by x, but it is multiplied by 3. 3 here. 3 times 2x squared plus x minus 1 will give you 6x squared plus 3x minus 3. Now I replace b to x minus 1 minus 3 times bx. I get the answers of the first and the second. I replace them and simplify. I get the final answer to x squared minus 9x plus 3. We have some slides like this one, example about the same one. Now we are going to the graph. Graphs are very, very important. And you can see we have fixed graph. Here, when the degree is even and when the degree is odd. When the degree is even and the leading coefficient is positive, you will get curve or parabola, its direction upward. And the end behavior, of course, you can notice here. Here, x going to negative infinity, but y going to positive infinity. Here, both x and y are going to positive infinity. Of course, we get this graph always when the degree is even, in 2, 4, 6, 8, and so on. This when the degree even and the leading coefficient is positive. This when the degree is even and the leading coefficient is negative. Here when the degree is odd, 3, 5, and so on. We get like this graph when the leading coefficient is positive. End behavior, of course, here can see that this graph going downward in the left part. This means when x going to negative infinity, y going to negative infinity. And here, x going to positive infinity, y going to positive infinity. This when the leading coefficient is positive. When the leading coefficient is negative, then when x going to negative infinity, y going to positive infinity, when x going to positive infinity, y going to negative infinity, like this. This is the end behavior. Of course, here domain and range all real numbers in both cases. Here, domain here and here in the two cases all real number, but the range here, all the values of y will be more or equal the minimum, because when the parabola going upward, its vertex will be minimum. Here it will be less or equal the maximum. Here the parabola are going downward, therefore its vertex is maximum, and its range y less or equal the maximum point. This is an example about it. Here he described the end behavior depending on the graph. This also the same. Here, of course, from the graph I know that the degree is odd number. You can see here. And the end behavior here, x going to negative infinity, y going to negative infinity, x going to positive infinity, y going to positive infinity. This mean here it's like this one exactly. This mean the leading coefficient is positive and the degree is odd. All of this are examples to find the degree and to find the leading coefficient and to find the number of zeros. Of course, by the way, what are zeros function? We studied it before. Zeros function are the solutions of the function. Solutions means what? Solution means where the graph intersects the x-axis. Always we have a graph intersect the x-axis, then we will have zero function. If the graph did not intersect the x-axis, this means we don't have real solutions. Last point in this lesson, how we graph. When he give me function like this, if x equal negative x cubed minus 4x squared plus 5, and you want me to make a graph. Of course, because before I start, I know the shape of the graph, because from the degree I can notice it. It's odd and the coefficient is negative. I can imagine the graph. But how I graph? Of course, we make table. We take values for x. Take negative values, positive values, 0, any values you want. But at least you must take 6 and more to get an accurate graph. Then you substitute here by the values of x to get y. You will get, as you can see here, 1, 2, 3, 4, 5, 6 points. You plot the 6 points, then you match to get the graph. Like this one. This will be the graph of the function.